Hello, this is Brother Cromar from the Math Department, and these videos are covering Lesson 17, which is describing categorical data, proportions, and sampling distribution of a sample proportion. And so here's the outline for this lesson. First of all, I'll cover a review, categorical versus quantitative data, what they are, and then I'll go over the graphs in terms of when we use each type of graph. And we'll discuss distribution of sample proportions, then finally finding probability for distribution of sample proportions. Okay, so first of all, let's review the difference between quantitative and categorical data. Quantitative is usually numerical. Okay, for instance, height is quantitative, so is body temperature, costs of new medical equipment, number of siblings, and a typical questionnaire rating. Okay, categorical is usually non-numerical. For instance, gender is categorical, class in college, race. Now there's one exception though that, for instance, phone number is numerical, but it's categorical. It's not quantitative. For instance, if you double a phone number, that doesn't really mean anything. So there are a few exceptions, like football jersey number. That's also another situation where a number isn't really a quantitative. It's categorical. Okay, so now here are the different types of graphs that you can do with categorical versus quantitative. Now back what we dealt with lessons or units 1 and 2, we dealt with histograms, and here's an example of a histogram. And then box plots as well too, that we can measure or we can view quantitative data with both of these types of graphs. With categorical data, there's 3 different types that are covered in the online textbook. First is the pie chart, then the bar graph, and then finally the Pareto chart, or we could say bar chart as well too. Now I want to pause for a moment and compare the difference between a histogram and a bar graph. Okay, bar graph, we do something or use data that's categorical. Histogram is quantitative. Notice here that the bins, if you will, are smooshed together so that we can look at the distribution of quantitative information. Bar graph, on the other hand, the bars are separated out by categories. So there is an important distinction between bar graphs and a histogram. Okay, and another thing is the Pareto chart is really a bar graph, but it's sorted in ascending or in descending order. So the highest frequent category starts first, and then it goes down to where we have the lowest frequent category. Okay, so now so then continuing. With categorical versus quantitative. Unit 2, we covered the quantitative data, or we dealt with testing with quantitative data. So the main parameter of interest for the population was mu, the population mean. Now for Unit 3, the parameter of interest for the population is P, which is the population proportion. So at the start of this unit, we will look at data that has 2 categories, those observations that have a certain characteristic and those that do not. For instance, in a general election, is somebody going to vote for the current president or vote for somebody else? So it's one or the other. Okay. So now let's go to distribution of sample proportions. Okay. So now what I'm going to do is I'm going to compare and contrast what you've seen before with quantitative data versus categorical data. So the parameter of interest for the population is mu for quantitative data, typically. The parameter of interest for the population for categorical data is P, or the population proportion. Now the statistic to estimate mu based on the sample is x bar, okay? And the statistic to estimate p based on the sample for categorical data is p hat, or the sample proportion. And now going to the left here, x bar has a sampling distribution. Here's an example. If you remember the distribution of sample means. Some classes did what was called the Great Penny Experiment, and this represents the distribution of nickels. The sample means. But over here on the right with the categorical data, p hat, which is x divided by n, where x is the number of individuals with a certain characteristic. So this here represents the sample proportion. And the distribution of p hat, it has a sampling distribution. And it can be, if we have a large enough sample size, and we'll talk about that in a moment, this can be bell-shaped distribution. Okay. So now let's go further with this, with estimation and sampling distribution. So the distribution of x bar, if you remember, the mean of the sample means is equal to mu, or the population mean. The standard deviation of the sample means is the population standard deviation divided by the square root of n. And if you remember with this, when we dealt with the normal distribution, when we had a z-score, or I should say with a sampling distribution, or the distribution of sample means, When we want to calculate a z-score, we would take the sample mean minus the population mean divided by the standard deviation over the square root of n. Okay. Now, going now with categorical data, the distribution of p hat, the mean of the sample proportions is just the population proportion. So similar to what we have over here, where the mean of the means is equal to the population mean, the mean of all sample proportions is just the population proportion. Standard deviation, on the other hand, is for the distribution of proportions or sample proportions, is the population proportion times 1 minus the population proportion divided by n, and then it's all square rooted. Now if we want to get a z-score similar to the z-score over here on the left side, we can get a z-score for this as well too, for the distribution of sample proportions. It would be the sample proportion minus the population proportion divided by the standard deviation that's listed up here. Okay. So what I'm going to do is I'm going to stop the recording, and in part 2 we're going to cover finding probability for distributions of sample proportions.